Hello, good evening, and welcome everyone to this evening's inaugural professorial lecture by Professor Claire Gwinnett, titled The Dust We Can Trust, Searching for Traces. I'm Martin Jones, Deputy Vice-Chancellor and Professor of Human Geography at Staffordshire University. And in the context of the daily chaos of higher education, of which there is a lot across the sector at the minute, welcome you here tonight is a nice part of my job. We're here to recognise and to celebrate the achievements of Professor Claire Gwinnett. Claire is joined this evening by her mother, Sandra, father, Don, her uncle and aunt, Terry and Pauline, her fiancé, Will, and soon-to-be mother and father-in-law, Dee and John. So no pressure, Claire, of course, in that context. This is also an opportunity for your family, for sure, to laugh at your jokes, as well as to share with your personal and professional journey. Thank you for coming. Thanks for everyone for joining online. Now, inaugural professorial lectures are an important part of business at Staffordshire University, and it's fantastic to see so many of you here this evening. The dictionary definition of inaugural is to mark the beginning, though I prefer to see this as the rite of passage when an individual leaves one group and enters another. At Staffordshire University, this means embracing academic leadership to develop more talented people and creative minds, as well as, of course, as furthering individual scholarship. Claire is already actively involved here in the roles she plays across the university, and particularly in the School of Law, Policing and Forensics, as the leadership person for the Centre for Crime, Justice and Security. A little about Claire's career and research before I pass you over to the Prof. Claire is currently Professor in Forensic and Environmental Science at Staffordshire University and has been working in forensic science for 17 years. She's currently the Director of the Centre for Justice and Security, which houses world-class research, innovation and knowledge exchange in all aspects of the criminal system. Claire's expertise is particularly in the analysis and interpretation of trace particles and particulates, both for the purposes of investigating crime, but also for understanding environmental pollution and pollutants. Claire is certainly acknowledged as one of the world-leading forensic fibre researchers, and has worked across leading international forensic science network organisations in forensic research, which have led to the recovery and analysis of polymers for the benefit of the criminal justice system, including improved contamination prevention protocols, and methods to automate the characterisation and identification of said fibres. She is currently the lead at Staffordshire University for the International Forensic Fibres and Microplastics Research Group, IFFMRG, which works with government bodies, research establishments, charities and industrial partners in 22 countries to provide global solutions to forensic science and environmental challenges. Claire's dynamic, innovative and collaborative research has gained her international recognition and reputation as a scholar who's generally world leading, and she's promoted this research with passion, purpose and action to lead to real changes in academia and policy practice. This is why we're here today, to acknowledge and to celebrate this. I will now hand you over to Professor Claire Gwinnett.
Hello everybody. Thank you so much for joining me tonight on my inaugural lecture. I am so honoured to be able to stand here and talk to you about my research, and also about a substance that you might not actually have thought about too much, which is this stuff here, dust. I have spent most of my career trying to understand how the particulates that are present in dust can help solve crimes, and can also help try to understand a bit more about our environment. So let's just think about dust for a second, and let's just think about what we might, when we see it, what we might feel about that. Many people don't actually sort of think about crime fighting when they see dust motes in the air. Most people just kind of consider how they're going to clean it up. But actually, what's present in dust actually tells us who's committed a crime, when they committed a crime, and can help reconstruct events. It can also start to give us some understanding about the pollutants around us and what we're actually exchanging from us being present in the environment and polluting our wider world. Now, it's not really the dust itself that's of interest, it's the things that make up the dust. And dust is a composite, it's a mixture of all the different materials that we come in contact with. So this includes things like building materials from inside and outside of buildings. It includes tyre particulates, brake particulates from just us using our cars. It includes pollen from all the plants, the trees that surround us. And it includes the soil that we may stand on and transfers to us and our environment. It also includes hairs, so this is humans and animal hairs. And maybe predominantly it includes textile fibres. And that is an area that I'm particularly interested in, because we are surrounded by textile materials, we wear them, and we cover and surround ourselves in our homes with these. And it's this here that's really interesting, because we are surrounded by a man-made world, but also a natural environment that is constantly exchanging particulates to us, and we exchange particulates to them. And it's this that really starts helping investigate crimes, because the particulates we're talking about in dust, they're not sort of static, they're not staying where they are, they're really dynamic. They're moving around, and they're not just moving sort of in short distances, they're moving around the world. They're locating themselves, sort of transferring from plants, like pollen, onto people, onto animals. The paint peeling from walls, from windowsills, that can transfer into our environment, onto us. And our textile fabrics, they're constantly shedding. So whether we are washing them, whether we're just wearing them, whether we're drying them, there's this constant shed that we're exhibiting. And that's really useful for crime scene investigation, because it means that every contact that we make, every interaction, whether that is in a violent crime or completely innocent, whether that is with humans or animals, then we're going to see this transfer, this exchange of materials. And that exchange is what allows us to be able to identify the who, the what, the where and the how. Now, I didn't come up with the idea of exchange, I really didn't. This guy here, this is Edmund Lockhart, and he, in 1920, he pulled together the ideas, the principles that we now absolutely trust today in forensic science. And one of those principles was called the exchange principle, which talks about how us as individuals can, if we come in contact with a location, we will leave behind traces of ourselves, but we'll also take them away. And over the years, we've paraphrased this into every contact leaves a trace. And that is the principle that we use in order to be able to start to investigate crimes. So let's consider a crime for a moment. Let's imagine we've got a perpetrator who has entered a house, and they have moved through the house, and then they've violently assaulted and murdered an individual. They then left that house, maybe through a back window in a kitchen. They've gone across the garden and they've gone over a fence. Think about all the different objects, items that they've come in contact with that are going to leave part of themselves behind. And at the same time, they're going to take away those traces, all those particulates that we take for granted in dust. Now, that is not a hypothetical case, what I've just spoke about there. That actually happened for the tragic murder of Joan Albert, and Simon Hall was convicted for that murder based predominantly on the fibres evidence that was seen at the scene, that he transferred from his clothing onto the windowsill, onto a fence and onto the victim's body. And it's so important to understand how that exchange can help lead to a conviction, but also the other questions it can answer in an investigation. Because it's excellent at identifying the who. It can provide some information about what someone looks like, their lifestyle. It's essentially a witness of who we are and what we're wearing. But it can also answer questions about when. So when did this person come in contact with that individual? And that is how we understand the persistence. We call it the persistence of trace evidence of these particles. How long it'll stick onto a surface for gives us these timelines. How it's transferred, so where on a person, also tells us about the contact. So is this just a hug, so something completely innocent, or is this a violent assault? And we will see this transfer of these particulates in a completely different way. And these principles have been used in many famous cases over the years. And some of these you might recognise here on the screen. Some of the victims. So there's the Sarah Payne murder, the Soham murders, the Stephen Lawrence case. And trace particulates were fundamental in the investigation of these. Now, what you see here is dust, isn't it? But this dust was recovered from an athletic shirt that was in the Maryland rapist case in the US. This person was a prolific offender who the police really had trouble identifying a suspect even to start with, because the person was really quite forensically aware. But one thing that was left behind was these dust particulates. And the analysts that were involved in this case investigated what the components of that dust actually was. And on the screen, this is some of the information, the particulates that were present. So we have pollen evidence. This is that large pink item there. That comes from an oak tree, and the size and shape tells us that. In the far right, we have got minerals that are present from dry wall, actually. And we can identify them using something called polarised light microscopy. And in the bottom right, we've got teeny tiny paint spheres, which tells us that these paints has actually come from an aerosol, spray paint, and it hasn't come from someone who is using this as a roller or a brush. Now, those just particulates, as innocuous as they seem, gave the police a very detailed description of this suspect, where he worked, where he hung out, and even the job role that he had. So specific that it identified him, and he also confessed. So the power of these particulates together to give this information for crime scene investigation is incredibly powerful. But this exchange we're talking about that's fundamental to crime scene investigation could be seen as a problem now, which it is, between us and the environment. Because over the last 10 years, it's become incredibly apparent that our presence in the world and the things that we leave behind, like debris, like plastic pollution, is transferring to the environment. And these are degrading down, and what we now know, these plastics degrade down into something called microplastics, particulates that are teeny tiny, that will be present in your dust. And we know that these microplastics are around the world now. We know that they've entered every single environment. We know that they're in our lakes, our rivers, our oceans. We know that that exchange has led to these particulates to even reach really remote locations, places where people don't actually inhabit. And they've also reached, via transfer, via this exchange that we're talking about, through the air, even to regions like the Everest region in the Himalayas, where microplastics have been found recently. It's also really quite shocking to find out that microplastics are being found in places that humans have never visited, so such as the deep sea, thousands and thousands of metres down. And a colleague of mine said to me the other day, the only place that we've not found microplastics yet is the moon. But we're expected if we went there and checked, we'd probably find them there as well. So we know that we're completely surrounded by these. And we've got to think about where they're coming from. We know that microplastics, when we find them in the environment, are predominantly textile fibres. So the fibres that I analyse in crime scenes are the things that we're finding in the environment as well. And they're from our clothes, they're from the washing, the drying and that shedding. And they're going into the washing machine and they enter our waterways, and then ultimately they'll enter our soil and enter the air. There's all this dynamic exchange we see in the environment. And just to show you what you might even expect to see in coming from your washing machine, just with a normal wash, this is a Cora ball, which has actually been used to be able to trap and capture fibres and other dust particulates, hairs, etc. in your washing machine. And we come back to that dust ball again. We use it for crime fighting, and now we use it to try and understand our pollutants. So that leads me to what I've been spending sort of my career so far doing. And I really thought about this. I thought about what actually have I been, if I could categorise this into three things, what is it that I've been trying to achieve? And essentially what I've been trying to do is trying to improve understanding of how these particulates can help solve crimes. And at the same time, try to develop methods and improve methods that scientists can use to detect them, to analyse them and interpret them. And then in recent years, to try and take all that knowledge that we've gathered in forensic science and apply that to the environmental world so that we can better understand the pollutants that are out there and the risks that they pose. So before I tell you about some of my work, I'll tell you about how I got here. And you might wonder, like, how does anybody end up looking at dust for a living? And it wasn't because I'm particularly, obsessed by cleaning, by the way, but there's been some drives over my life, some choices that I've made that have led me here. And, I'll just share some of those with you. So going back in time, I was a child who was very inquisitive, who absolutely, I would say, loved adventure and always loved travel. Just here on the right hand side, this is a photo of my first ever journey outside of the UK. This is when I went to go and visit my Uncle Terry with my mum and my dad, who you can see here, and here they are. and my mum was completely convinced that actually that was the thing that led me to being sort of like really driven to go and travel the world and go and explore new things and meet new people. I was someone who loved boats, the ocean, ever since I was really small. I'm convinced a little that I was like a sailor in a previous life, and this has been really helpful later on when now, instead of crime scene samples and being in a laboratory, I get the opportunity to go on boats and to go and actually experience the ocean to try and investigate environmental problems. I was also a really big animal lover, and that really defined some of my choices early on. I was completely obsessed by this cute thing here. This was my Welsh pony called Blackie, and I was absolutely sort of just, completely obsessed with her. And part of that and that obsession with sort of riding and horses initially started to sort of like make my career choices. So I wanted to be a jockey originally, which my mum said was incredibly dangerous, but my dad supported. But I obviously changed that. And I then wanted to become an actress, actually, and not just any actress. I wanted to specifically be Julie Walters. That's who I wanted to be. I then changed and I become really interested in science. And I started to move towards maybe a career with animals. So I thought veterinary science might be the thing for me. And I chose my A-levels, all the sciences based on that. But about partway through, I realised, actually, I really wanted to join the police. And I wanted to be part of an investigation team, and ideally I'd be part of the mounted police to combine all these real interests together. But what happened back then, and I believe still does now, of course you have a medical examination and there's certain sort of thresholds you have to meet, specifically with your eyes, whether that is corrected or uncorrected. And I never passed, I never met that threshold. I'm incredibly short-sighted. For those of you who know prescriptions, I'm like -7.25. So I never got anywhere near the threshold that's required to be a police officer. And I was fairly inconsolable, until my mom said, have you thought about forensic science? And I said, oh, I don't know. I've not really heard about it. I knew a little bit about it from the TV, but I never really considered it. And at the time, there wasn't many universities who actually did this, and there was just about 6 in the UK, because traditionally people went into biology or chemistry and then moved into forensic science. But I thought, well, let's go straight into this. And this is what led me to Staffordshire University. And this is what it looked like. This is the Mellor building back then. This is where forensic science was based. This is where the labs were. We've got a science centre now. Things have changed over the years. But what hasn't changed is the absolute passion and knowledge of the staff. And that really drove me forward and just guided me to knowing this was a career I absolutely wanted to do. Now, in my final year, I started looking at trace evidence. And my first ever research project was investigating boot polish, which at the time people were saying, well, why would boot polish be evidence? But actually, this was based on a case where an individual said he'd been taken into custody, and during the night, a police officer had beaten him up. And the proof was some boot polish that was seen on the person's T-shirt. And the questions that the investigators were asking were, well, can you link boot polish from that stain to a particular boot or to a particular brand? Can you differentiate between them? And that's the research that I looked at. I looked at the value of boot polish and whether you could tell the difference between them. And that really kicked off trace evidence for me, and this idea of exchange and how important it is. And that continued because I got offered the opportunity to become a PhD researcher here. And at the time, a PhD researcher was not just doing your thesis, it was also getting involved with lots of other projects, which I'm incredibly thankful for till today. I was one of 4 PhD students who started, and looking back, there was just the 4 of us then, and now in our Centre for Crime, Justice and Security, we have over 60 PhDs who are all working to investigate something within the criminal justice system. We look very young and youthful here. We're really eager. We're all about solving crimes, changing the world. And my area that I looked at was forensic fibres and how we can generate large-scale databases. So this was taking the idea that for us to be able to interpret this type of evidence appropriately, we need to have a lot of data about how common we might find it at crime scenes, where it might come from, and how it might act, so how it transfers and persists. And large-scale databases were problematic because a lot of them were out of date. Ones that are in existence may not be accessible to all. So I developed a way forward that helped generate data in a cost-effective, timely way so that investigators could use this. And this led to me doing quite a lot of work about quality assurance because I used a proficiency testing approach, which was based on international standards, what we call ISO accreditation standards now. And I formed that and tested it out in order to be able to identify how well we'll be able to interpret this and generate this large-scale database. Now, this is something that's kind of always been there. I come back to this research a lot because we still need more databases now. We still need more information to be able to maximise the amount that we can use this form of evidence. So I very much wanted to learn a lot from lots of different people. And, that was kind of part of the PhD process. It's what really sort of fed into how can we use these databases worldwide. And this really helped when I started getting wider collaborations. I didn't want to know just what was going on in the UK. I wanted to know what was going across Europe. So how can the things that I do for research have global impact? And this led me sort of to my first major collaboration. And that was with Avans University, which is based in Breda in the Netherlands. And I met the team there who deliver forensic science education and research over a decade ago now. And they have gone from someone who I've learned from to inspiring researchers to my friends, and I now class Avans as home. Because over those years, I've been a visiting lecturer now, and I've had the opportunity to teach lots and lots of students, and this is one of my first group of students that I got to teach about trace evidence and how we can gather information from this type of thing. And what's great to see is now I know some of these students have gone on to go and work into trace evidence careers. So I know it keeps moving forward, and I know this knowledge will empower investigations in the future. So actually, this collaboration that just started off just between 2 universities expanded into something much bigger. And we received something called Erasmus Plus Strategic Partnership Funding, which is all about creating networks so that we can knowledge exchange, so that we can share ideas, do collaborative research and improve our curriculum for our students so they are not just students that can just work in the UK and Netherlands, but they're international students. And we developed something called EFEN, the European Forensic Education Network, which had many successes and now is still seeing firm collaborations between us all, where I personally have had over 50 different research interns come and work on trace evidence projects with me, all from this group of individuals. Now, I'm just going to move slightly to something else that happened during my early career as a researcher, and it was my first ever media experience. And it was a particularly interesting one. So I got phoned up by the BBC to ask to talk to me about what is it like to be a trace evidence analyst, someone who works in academia but works with the police at the same time. And because they wanted to build a character that was very similar to that for their TV series called Silent Witness, which is one of the few TV shows I actually really enjoyed that looks at crime investigation. So I was absolutely thrilled. And working with them, we looked at what kind of plot lines, what science can do, what science can't do. And eventually we ended up with this character here. And this is Parsons, who was a strong forensic scientist who investigated trace evidence and helped solve the crime in that particular episode. What I found from that learning experience was the real need for scientists to be able to clearly communicate science to the public, and all the different problems and challenges in doing so. So as a first opportunity, I started to understand what's required so that individuals know what we can do in forensic science and also what we can't, so some of its limitations. And I keep remembering this communication and the requirement for all of us to do that all the way through my research. So wherever possible, I always try to translate it in many, many different ways so governments can understand it, and then someone who's just interested in science can understand it as well. Now, I'm going to pick a few of the kind of projects and that I've done, and I'm going to pick some maybe more unusual ones, just kind of see how trace evidence can be used in different ways. And one piece of work that I did was I did a consultancy project that was working with the Freud Museum in London and also the Listen Gallery, which was an art gallery in London as well. And what this was all about was trying to understand the types of exchange that could have occurred between individuals and Freud's objects. So if you know who Freud is, he's a very famous psychoanalyst who has been portrayed in many different films. And when he gets portrayed, he normally gets portrayed with his examination room in his office. And you normally see the couch. So what we have on the screen here, this is the layout in the Freud Museum of the couch and his office chair and all of his different items that he had. Now, back then, this is what it looked like. But the two things in common here is that examination couch. It's covered in a Persian rug that's believed to have been gifted to him by his cousin. And that has always been the mainstay. And this has been what patients have laid on while he's been examining them. Now, two artists came along. This is Adam Broomberg and Olivia Shanrin. They had this idea of how do we translate the science, this exchange, into art? And they commissioned myself and a colleague and friend, Dr. Laura Walton-Williams, to go down to the Freud Museum and investigate all these items exactly like as if it was a crime scene. So we put up crime scene tape, we took photographs, we documented it like a crime scene, we searched it using light sources that we would use at a crime scene, and we recovered evidence like we would. So we used tape to be able to recover the trace particulates that may have transferred onto Freud's couch. We used tweezers, we collected the evidence. And from that, I wanted to try and produce something that showed this transfer. Now, from the artist's point of view, they were wondering whether this transfer could have come from all the way back when Freud had patients. So some of his famous ones like the Wolfman and Dora. Or is it just from the hundreds and thousands of tourists that have come and visited that area in London? And to me, it didn't really matter because it still showed that exchange, that the presence of all these people is being left behind. And these are some of the images that were created from that. These are some textile fibres under something what we call cross polars from Freud's couch. This is a cat hair that we found on one of the cushions, also on Freud's examination couch. This is actually a grey hair, grey human hair, but what has been done here is we've actually exhibited some of its optical properties called interference colours. It's something that analysts use to identify what it's made out of, but here it's been used artistically. And the thing that really got me about this work was that the artists took what I just take as sort of standard, the kind of images that we create for this kind of analysis, and they made art out of it. They made a tapestry, they made installations, and they explained it as trying to translate science into something artistic. And I found that absolutely fascinating, because I never looked at evidence in this way before, in something so creative and actually quite beautiful. Now, another area that I'm really interested in, and I have been for many years now, is how these trace particulates can be used not just in human crimes, as in crimes to humans, but also crimes to animals. And I'm talking about wildlife crime investigation and things like animal abuse cases. Now, when we think about wildlife crimes, it's a hugely prolific crime. It's been in the media more and more, particularly since COVID-19, where links have been proposed between wildlife crimes and the COVID-19 pandemic. But the sheer number of poached, illegally imported, exported animals and products that have come from this wildlife trade is huge. And some of the questions that we ask of these crimes is, well, who is the victim? What item, what species, what animal has these little products come from? And how can we do that? There's so many. How can we investigate whether this is a crime or not? So, remembering these types of particulates that are present in dust, I mentioned hairs. And hairs are incredibly important for wildlife crime investigation, because it helps identify or helps answer the question, who is the victim? What species has this come from? And sometimes, obviously, that's very obvious if we have a full pelt or a full skin. Most of the time we don't. We have single hairs of items that have been made into trinkets and things to be sold, and we may get seized at airports. So we might have just a few individual hairs be able to tell us what species it is. And it really can do that, because animal hair is very, very different species to species, and even between subspecies. The intricate detail, the structure, the morphology differs between animals, and you can see this here between these three different species. What we see here is we'll have some differences in the outer layer. That is the scales. This is what we call the cuticle. We'll see some differences of the cellular structure that's running through the centre. We call that the medulla. And we'll see differences in the cortex. This is what's surrounding that medulla, in the amount of pigment and the different colour variations. But an analyst who looks at this is not just looking for one feature. And animal hair analysis, like all hair analysis, is like searching for your friend in a crowd. If you were trying to identify your friend, you wouldn't just be looking for one feature, like the nose or their eyes. Instead, you're looking for all the features that make up their face. And that's exactly the kind of thing that you need to do when we're doing hair analysis. We look at all of the features, and then we come to a conclusion of what animal that could have come from. Now, I've used that principle for some years now, and I've had the fortunate opportunity to be part of a number of wildlife crime cases. And some of these have been, for example, bushmeat that has been seized from a London market, and the question was, is this gorilla meat or is this from something else? And I'm glad to say it wasn't gorilla meat. It has been in things like cases where we've got badger baiting, so this is the poaching of badgers, and also in what we see on the screen here, in a deer carting cases. And the case that I refer to here was in Northern Ireland, and it actually got quite a lot of media attention over there, because what is illegal about this is taking deers, putting them in trailers and transporting them to a location where they then get released for hunting purposes. And some hares were seized from a trailer. The deers were no longer present at all, but there's some hares. That exchange happened between the deer and a trailer. And I was asked, is this of deer origin? And I could confirm, looking at all the morphology, that it was of deer origin. But something came to mind when I was doing this research, which was, well, there's a lot of species out there that we don't have or knowledge of the characteristics to be able to make that conclusion. And we don't understand how varied they are between maybe species that are really related. And that led me to a piece of research with UNESP, which is a university in Botucatu in Brazil, who are incredibly motivated to investigate wildlife crimes, and particularly those that occur in Brazil. So I had the opportunity to go over there and actually train vets in this forensic hair examination, but also to sample these creatures here. And part of this research was about sampling from mammals and also avian, because avian species have feathers, they shed, they are also trace evidence. We can identify a species from the morphology of feathers. But we wanted to take samples of these in a non-invasive way, so we were able to characterise them and produce a toolkit. And just so you know what these hairs look like, we've got brown howler monkey on there on the left, we've got a jaguar in the middle, and then we've got a cougar on the far right. And from these characteristics, this toolkit that we created now allows other analysts to be able to identify the presence of these species in wildlife trade that is occurring in and out of Brazil. So a lot of the time it's about that illegal export of goods and of live animals out of the country. Now, about 6 years ago, my career took a tiny little sort of pivot, and it started to think about, I started to think about, how can I apply some of this knowledge that I've gained in forensic science, how can I apply that to the environmental world? And this started off by having a phone call again from the Natural History Museum, asking me to be involved in a project that had taken samples from the deep sea. On board the ship here, the HMS James Cook, using remote operated vehicles, taking sediment samples, but also different organisms that live at really, really great depths. So some of these are all the way down to 1,800 metres. What they were interested in was the presence of microplastics in there. And they'd heard about the fact that I did a lot of forensic fibres work and wanted to know whether I could apply my forensic techniques and knowledge to these samples here. Because one challenge or one question that came up was the fact that we might only find a very, very small amount of microplastics in this incredibly remote location. And how can we be sure that those microplastics haven't come from what we call procedural contamination? Something like in the laboratory, where we're shedding fibres from our clothes in the lab or from the environment, from airborne surfaces, that then end up in the sample, and then we end up saying there's microplastics present when in fact they weren't from there. They weren't in the environment to start with. So in forensic science, we have many different protocols that we use to reduce this procedural contamination. We are very aware about transferring and exchanging these particulates. So we developed a series of different protocols and guidelines that now gets used, I'm happy to say, it's been used at the moment in just over 210 different studies worldwide. That takes forensic science and everything that we do to try and prevent or monitor that contamination and apply it to the environmental world. And this was really the springboard for my work there, because at the time I thought, is this it? Is this the only work that I will do? But then I realised there's a real gap in environmental work, in particularly microplastics, with the forensic side of things, and that forensic fibres can give so much information and it can really help move forward the technology and the methods, and we need to communicate about that. And from that I got the chance to talk at length in many different organisations all the way around the world, from Croatia to Woods Hole Oceanographic Institute in the US, with US government groups, and with the likes of the National Great Rivers and Research Centre, who look at analysing samples along the Mississippi. And what I sort of found out there is that we can do a bit of knowledge exchange, because there's certain things that I can learn as a forensic scientist about this pollutant in the environment, and at the same time there's things that I can give about how best to analyse these samples, because remember a lot of them are textile fibres, in order to be able to better understand how much is out there. And this has led to lots of different work, and just one I'll briefly pause on, which is something that we've taken samples, and we're still processing those samples in fact, but this was my first ever citizen science project, which was recruiting divers, recreational divers, on board a diving vessel on the Great Barrier Reef in Australia. And what we would do is we would introduce the idea of microplastics and how the sampling techniques, and then I would get my citizen scientists to go and take samples along with myself from sand samples, so the sediment from around key reef areas. What I got out of that was the fact that I could see people were engaged because they love the ocean, they're divers, and then they were asking me questions like, us being here, will that leave microplastics? Will they come from the boat? Will they come from us and our dive suits? And the answer is yes. So it opened people's minds to that your presence in a natural world is leaving something behind. Now, the main relationship I'd like to discuss, or to tell you about, is one that I'm very fond of now, which is the Azalea Project, which is based in the US, and who is an organisation who is driven to guide and problem solve using science, and at the same time engage the public so we really can make positive change. And I got awarded something called the Winston Churchill Fellowship, which allowed me to sort of start learning from lots of individuals and start building these collaborations. And this one here actually led to a National Geographic funded expedition all along the Hudson River. This expedition happened in 2019, and we had lots of aims, which was around mapping microplastics all the way from the start of the Hudson River, which starts all the way up in Lake Tear of the Clouds in the mountains, really remote region. Every 3 miles was sampled all the way down to where the river meets the ocean, which is Ambrose Light. And at each of these locations, we were taking water samples, air samples, and even soil samples from the bank to try and see how many microplastics were present. And we were utilising some of the forensic techniques that I've been using for, criminal investigations for the purposes of examining these types of samples. And this is the crew. So we're on board the American Promise, which is a very famous, what was a racing yacht, and now is an eco yacht that has been built or has been changed for research. And as a team, we sampled along that river, and it was hard work. It was hot. There was a lot of samples taken, and we did all of that on board the boat. So just to show you here, we took water samples using something called a Niskin bottle. That's what you see on the left. We took air samples using the pump, and then we were recovering these in the lab, which actually was the galley, which is the kitchen, using a forensic tape, something that I and a colleague of mine, Professor Andrew Jackson, developed for the forensic world, because this particular tape allows us to be able to quickly sample, prevent contamination, allows us to transport it around the world, and also allows us to analyse all the samples within the tape, which is really useful for forensic work, but it turns out actually is incredibly useful for microplastic work as well. And we recently published on that, this use of this forensic tape in the environmental world. And part of that process and that experience was realising as a scientist, who I'm normally in a laboratory and in a very controlled environment, is all of a sudden doing science on board a sailing vessel, and we are the scientists and the crew, which afforded me the fantastic opportunity to, do all the boating things that I wanted as a child, and even get behind the helm, by the way, which was fantastic, and I'll never forget that. And to try and adapt the approaches I would use in a lab, but within a non-science environment. So you're looking at the galley there. This is just where we're just setting up ready for analysis. These are my 2 PhD students who came on board with me, and we're trying to do science in this environment. And questions were asked from that, because this is the environment that a lot of people take samples when they're looking for microplastics. But how do they control for that procedural contamination that I talked about before, the thing that kicked off my career in this? And we developed some incredibly strict protocols for on board this vessel. Very, very strict about taking controls. So we know that there's going to be procedural contamination, but we want to know where it's come from so that we can get true amounts of the microplastics in that sample. And this is just a bit of an overview of some of the things that we did there. And we wanted to test this. And one of the studies that we did on there was, well, what would happen if we took away all these controls? That's just to add here that the vast majority of microplastic studies do not put in place at all. They don't try to protect the samples. They're just taking them. And we run a study where we remove them, and we looked at how much of this contamination we actually from ourselves, from on board the boat. It's actually not from there. And this is the only bit of data that I'll pop on here, but I think it's quite shocking, because when we remove these protocols that we've developed, 69.74% of across these samples that we were finding that were these materials that we were trying to recover were actually procedural contamination. So they weren't in the environment to start with, they were added in. But the other thing to add is, even when we've got them in place, there is still procedural contamination there. And we have to acknowledge that, and we have to make sure that we can control for it and make sure that the end result that we put out there isn't overestimating the amount of microplastics, nor do we want to underestimate. It's about getting quality science. And as my colleague Rachel Miller, who runs the Azalea Project, said, we're all a bit like Pigpen from Peanuts. We're constantly just shedding things, and we're shedding them while we're doing sampling, and we're shedding them in our environment, and we're shedding them at crime scenes. And when we remember that, we can find some really important answers. So I'll just say now what's next for me. I've got lots of projects, and I really want to drive forwards and build on the stuff that I've already done. And a lot of that is around the environmental work, but it's also in the forensic world as well. So for example, I'm involved with Nectar Mission, who took samples in the Weddell Sea, which is actually, we're looking at ice cores, and the presence of microplastics are there. I'm working with a university in Turkey that's looking at plastic pollution in the agricultural sector. And I'm investigating how long fibres stick on clothing fabrics, so imagine on a victim, if they're submerged in water environments. So imagine a body being dumped. How long would we expect these particulates to last for, so we can get timelines? And then finally, we've very recently started some collaborative work with the Forensic Wildlife Academy in South Africa. And this organisation is all about knowledge exchange. It's about training the next generation of analysts and those on the ground now who are fighting poaching out in Africa, and at the same time doing some world-class research. And one of the aims there is to start thinking about spreading that knowledge outside South Africa and into Europe as well. Now, I've come to the point where I need to do some thank yous. And if I get through this without crying, it'll be absolutely fantastic, because I have had so much support over the years, and every single thank you, I just don't have the time for it, because I've worked with so many different fantastic scientists in organisations all the way around the world. Prestigious scientists who have given me insight into worlds and ideas that I never thought I could have. So thank you so much for that. Thank you for my past and present colleagues, those who were there as part of my PhD, and those who encouraged me to do a PhD. I have Dr. Graham Harrison here on the far right hand side in his lawyer outfit, and he encouraged me the whole way through my degree into my PhD and helped get me the job where I am today. And I want to say a special thank you to my PhD cohort back then. There was highs, there was lows, but the whole time we were driven to change the world, and we had a fantastic time doing it. I now have lots of collaborators around the world who are all driven to solve environmental crime scenes. And two to note here is George Varghese and also Albert Privato. We consider ourselves the Three Musketeers in the terms of environmental forensics. What we're trying to do is get this global network together so that we can share ideas and we can improve the science behind this. I want to thank my research team, all of my PhD students who want to change the world, and that completely motivates me as well. And in all aspects of work, whether that's microplastics or whether that is in trace particulates for crime scenes. And I want to thank Lucy Woodall, Dr. Lucy Woodall. She's the scientist who phoned me up from the Natural History Museum and who changed my career absolutely for the better. So thank you, Lucy. I want to thank Professor John Fairburn for motivating me and supporting me in this professorial position. I honestly owe him that push to actually put the application in. And another colleague here, Professor Andrew Jackson. He's my PhD supervisor. He's been my mentor for now nearly 2 decades, and now my friend who we work on such really important projects in the criminal justice system. Thank you, of course, to my friends and family. Love and support that you've given me just allows me to be able to fly in this area. And also, I do thank them for all of the times I've requested them to give me or donate hair samples for research, sometimes from quite unmentionable places. So I really thank you for that. I also now just want to thank Dr. William Bailey, who is a superb expert and research in his area in his own right. And I learned so much from him, and his support and love allow me to do exactly what I get to do here in my job. And then finally, my mum and my dad, who I try not to cry now, because without them I would not have entered this career. I had a fantastic childhood that allowed me to be able to do exactly what I wanted and become the professor. So thank you so much for that. And then I just want to sort of say thank you to all you guys for listening. And if you're a student out there, I want you to consider your career and how it can change. And it might be that you end up as an expert in one particular area, but then you end up working in, as for me, with vets, with marine scientists, with sailors, and it just makes you realise how exciting a career can be, even if you start out just thinking about what does dust tell you. Thank you so much for listening. It's been an absolute pleasure. Thank you.
Thank you very much, Claire. Such an interesting and engaging lecture. We do have some time for Q&A. So if you don't mind answering a few questions, if anyone would like to ask a question, please pop them in the chat and we will try and get through as many questions as possible. So first question, Claire. Can feathers be used as trace evidence, and can you tell what bird a feather belongs to?
That's a really good question. And I will try to keep this short because I could talk about this for hours. So it's a particulate type evidence, and though we talk about trace, a lot of time we think about trace as very small items, don't we? But for the purposes of feathers, think of it like transfer, a particulate, an item that can transfer. And when that gets transferred, maybe even just a single feather, we're able to look at its morphology, both at a macroscopic level, what we mean by looking at it by the naked eye, the colour combinations, some of them are spotted, some of them are banded, the shape of the feather. And then at a microscopic level, we can look at individual features that make up that feather. And what's is fascinating about feathers is it's a bit like when we look at a leaf and then each of the veins break off into another little vein, and that's what happens with feathers, and you can see that microscopically. Now all of those features together, a bit like hair examination, come together to lead to what you think is the species that it's come from. Now depending on how much feather you have can determine how confident you are in that conclusion. So we've only given a very small amount of feather, or it has been changed in some way to maybe make a trinket. So we might see these in earrings or things that have been made and then of course taken, but actually they're from an endangered species. It might not present its original features. So we have to account for that. And the main thing that we need for that is these large scale sort of reference collections and that knowledge, the research behind, well, what would we expect to see for each species and how do we handle something that might have been changed in some way? I hope that's answered that question.
It definitely does. The next question is, if someone wants to get involved in environmental science, how would you suggest they start?
Oh gosh, yes. That's well, I urge you first of all to definitely get involved in environmental science. There are some traditional ways of entering environmental science, and there are environmental science degrees which will give you the breadth of information and knowledge and skills that will cover all different aspects of the challenges in the environment that we face today. So it's not just about plastic pollution, it's also about climate change and all of the other things that we now are seeing as global challenges. There's nothing stopping you though sort of moving into this area from a particular discipline, just like how I did. I didn't start off in environmental science, I just applied my knowledge there into the world of environmental science. And environmental forensics is an area that is incredibly important, not just for plastic pollution and wildlife crime, but think about oil spills, think about waste spillages, think about leachates from even dumping grounds. So you know, it's all about waste management. And there's many opportunities to enter that, whether it's at an undergraduate level or whether it's at a master's level, whether it's even as part of your job, but you end up gaining an expertise in that area. I definitely urge, though, anybody who's interested in that to really pursue it, because you know we're facing a lot of challenges. We're now obviously more apparent than ever of our impact on our environment, so we need as many scientists as possible to really join the fight, really.
Thank you, Claire. The next question is, what analytical techniques do you use?
So depending on the sample, we can use a variety of different types, and actually the trace evidence analyst has got like just a huge menu of different techniques that they can use. What is good to add here before I mention a few of these is the need or the better conclusions that you can come to when you apply more than one technique. So we should never just rely on one particular technique, just like microscopy or polarized light microscopy, but we should be adding information. I sometimes call it like the layer cake, so I keep adding layers of information about the sample so that we can end up answering some of these questions, like where it's come from or whether we think it's come from a common source. So some of the techniques that we might use are things like Fourier transform infrared spectroscopy, which helps tell us what things are made out of, as does Raman spectroscopy, and they're very complementary, those two techniques. We use scanning electron microscopy, which gives you fantastic high resolution images, so we can see the outer surfaces of samples, which is great for hair examination. But we also want to quantify the colour in some way as well, because if we think about textile fibres, think of all the different colours that you can have in your wardrobe, then we know that colour can help either eliminate samples, or it can help come to the conclusion it's come from that particular garment. So we use techniques like microspectrophotometry and things like thin layer chromatography to help sort of quantify the colour. I hope that's answered that question. There's lots more techniques actually, but I'll just give you some of the key ones.
Brilliant, thank you, Claire. So you've talked about a lot of projects, all important, but which one do you think was most impactful?
That's a really good question. I think actually some of the work that I've done, I just briefly mentioned it really, which was about the tape, the forensic tape, because that forensic tape actually is only one aspect of some of the work that we're doing. Because what we've noticed by working with and me and some of our colleagues, working with police forces around the UK and globally, is that there's some challenges that trace evidence analysts face, and a lot of that is around cost and how expensive techniques are, and also that, some of the ideas from police forces about what's the value of this. So we're trying to improve the value of that evidence so it can help investigate crimes. But to do that, we have to make sure that the analysis is, like I say, more time efficient and cost effective. So that tape was developed with a lot of organisations around the world to try and answer the first part of that, which is, can we speed up the process of recovery, a bit like how I did from Freud's couch, to the analysis? Because previously, unless you're using this tape, you'd have to take out every single little particulate to analyse with all those different techniques, whereas that tape allows you just to do it in there, so that speeds it up. But that is part of like a chain of different processes that we're trying to improve, and that includes kind of really harnessing technology today and harnessing something called artificial intelligence, which you'd have come across, in order to be able to develop automated systems. So instead of science, forensic science, environmental science being manual, and we are looking at every single piece and it takes a lot of time, and then there's human error, instead let's get very well calibrated and designed machines to do it, so that we can get so much more information from samples and ideally get it real time. So imagine a situation where you have an investigation and a police officer is allowed to get fast results, which will help identify what strategy should happen within that particular crime. Start identifying suspects sooner so we can remove those from the streets and reduce threat to society. So I would say that is probably one of the things that I can see that is game changing, and it will change the way that forensic science for this type of particulate is done, hopefully forever.
Brilliant. You mentioned your PhD students, quite a large number of them actually. How important it is for the university and for yourself to offer this opportunity to go on and carry on with the PhD? What do you think students get out of this experience at the end of it?
The PhD experience is absolutely fantastic. It's not always easy, of course, but what it does is it takes someone with motivation, someone with enthusiasm, but maybe not a massive amount of knowledge about a particular area, and it develops them into the expert that they ultimately become, and a world expert in that particular topic. And along the way, it develops them into a researcher, and all the different skills that gives you. You get to collaborate, not just with yourself and maybe someone who you sit next to, but you'll collaborate with people the other side of the world. You'll do joint projects together. You'll learn from them and they'll learn from you. And then ultimately you come out the other side, slightly weary, but nevertheless the expert in that area, that people then come to you to answer questions. And that is such a leap in terms of in a career. And it changes. You don't have to stick in that area. It can change, of course, but the skills that you gained in your particular topic, you never lose. So again, if you're driven for global, world-changing research, if you want to change the world, then a PhD research is absolutely for you, I would say.
Brilliant, thank you. One of the questions that we have here is, what do you see as the next great challenge to overcome, to improve going forward? Greater databases, working better with agencies, or better understanding and education, or something totally else?
That's a fantastic question. I think you almost answered it yourself there, because each of those three things there are massively important. We are, in the world of sort of criminal justice, we are at the point where hopefully, you know, positive change is happening as well. We're constantly improving. We are getting better, better at the analysis of these particulates, but some things still need to be improved. And that does include the things of like education of those who make the decisions about what to do in a case. Because for the likes of trace evidence, sometimes it kind of gets forgotten a little bit. It's a very traditional form of evidence, it really is. This has been going on for years and years and years. Look at like Edmund Lockhart started writing about this and was thinking about particulate evidence in 1920. But of course, with the introduction of DNA, which is fantastic, with the introduction of digital forensics, sometimes that disruptive technology can leave the more traditional particulates to the one side. And I think the challenge is understanding where this fits in a whole investigation. Whereas other evidence is fantastic at the who and answering like DNA and finger marks and saying exactly who came in contact with what. Trace evidence is all about the what, the when, the where and the why, and it's helping to construct that dialogue around the case, and that's the thing that leads to more confident convictions. You know, we should be reconstructing crime scenes and we should be utilising any evidence that's present there. So the challenge to try and get it back on the map, I sometimes called, and making sure that it's used in all different casework. And please don't think it doesn't get used. It gets used in serious crime all the time. It really, it really is. And it's, as we saw from those different cases, incredibly important. But what I would like to see is this form of evidence being used for volume types crimes. So things like burglaries, car thefts. And those are the crimes where it doesn't get used so much. Yet it can tell you who the driver was. It can tell you who broke in. And when you've got crimes by prolific offenders, of those who are actually very good at committing crimes, they're not leaving DNA, they're not leaving finger marks, but they can't help but leave the particulates from their clothes as they climb through windows and they commit that crime. So from my point of view, trying to use forensic particulate evidence in those crimes is the new challenge, and I believe and I hope it will be reintroduced in that area. It's one of the areas that we're certainly pushing here at Staffordshire University.
Thank you, Claire. We don't have any more questions. I just wanted to let you know, and I'm sure you can have a look later on. Great feedback by all the attendees on YouTube. A lot of friends and colleagues from Netherlands, as you mentioned, and they thanking you for putting up the photographs. So thank you very much, Claire, again for this lecture and for answering all the questions. Thank you to you all, our attendees who joined us. If you would like to watch the lecture again or share it with your colleagues, please do use the same link. This lecture will be available on demand straight after we finish. And if you wish to watch any other events, you can go at staffs.ac.uk/events. I hope you all will have a good evening.
Thank you.